In this session, we are going to discuss about blockchain technology. So blockchain has gained popularity in recent years as a potential solution for a variety of industries. We are talking about finance, healthcare, supply chain management, etc. It is also a technology that underlies digital currencies like Bitcoin, as most of you might have heard about. So in this presentation, we will explore the origins of blockchain. We'll talk about how it works, what is public blockchain, private blockchain, what are the use cases for this technology, what are digital currencies, how security is integrated into blockchain technology, what is crypto mining, and what are crypto wallets. So the first definition that we're going to talk about in blockchain is a decentralized distributed ledger technology that enables a secure and transparent transaction without the need for any intermediary. At its core, blockchain is characterized by three key features. These features are decentralized, distributed, and immutable. So let's discuss each of these core features. When we are talking about decentralization, the meaning is that there is no central authority controlling the network, as opposed to the financial systems that we know about today. We have, for example, banks. The bank is a central authority who controls the transactions of money. When we are talking about a blockchain network, we are talking about a network that doesn't have a central authority that controls it. The second core feature is the distribution, which means that data is stored on multiple nodes across the blockchain network, which ensures the integrity of the system. We will elaborate it later in this session. And the third and one of the most important features of blockchain is the immutability. This feature is basically ensures that once data is recorded on the blockchain, it cannot be altered or deleted. Guys, do you have any questions about these features that we have discussed about? Please write them in the chat. Okay, that's cool. So let's talk about the origin. So blockchain technology was introduced in 2008 in a white paper written by an individual or a group of individuals using the name Satoshi Nakamoto. This white paper proposed a new type of decentralized electronic payment system called Bitcoin. This electronic payment system was designed to operate without a central authority or intermediary, as we said earlier. This cryptocurrency was opposed to the banks. We don't want any intermediary, any central authority to control the transactions. We want it to be distributed as much as we can. So the key innovation of Bitcoin system was the use of blockchain, a distributed ledger that records transactions between parties in a secure and tamper-evident manner. The blockchain allows multiple parties to reach consensus on the state of a distributed database without a need of a central authority to validate and process transactions. Now, the original Bitcoin blockchain was launched in 2009, and since then, the technology has been applied to a wide range of use cases beyond just digital currencies. We will elaborate it later. So today, blockchain technology is being used to build decentralized applications, improve supply chain management, enhance cybersecurity, and more. Do you have any questions about the origins of Bitcoin? Okay. So how does it work? So when we talk about blockchain, we need to understand that blockchain is a digital ledger of transaction that is distributed across a network of computers. Each block in the chain contains a record of multiple transactions, and every time a new transaction is added, a new block is created and linked to the previous one. You can see in the image that I've put in this slide, a blockchain is a network that has a ledger. This whole segment that I've circled is the ledger. It consists of all the transactions that ever been made on the network. Now, these transactions are divided into blocks. That's why we call it a blockchain. We have blocks that store data. The data is the transactions that we have made. The blockchain is composed of many of these blocks that cover all of the transactions that were ever made on this network. And they are chained to one another through an algorithm that is known as a hash algorithm. When I create a block, this block has a specific hash string that is attached to it. Now, the next block, block number 2, for example, will contain the same hash of the previous block, and then will create a new hash for himself. The third block in the chain will have the previous hash of the block number 2 and will create for himself a new hash. And this is how it is chained. Now, let's say, for example, that I have a malicious actor in the network who tries to write that he has, for example, 10,000 Bitcoins, or he wants to steal money from other wallets. So it tries to rewrite the transactions on block number 2. The meaning of him trying to change the transaction in this block will cause this hash to change. So, for example, instead of 6BQ1, we will have a different value of 45YU, for example. Now, if we will look on block number 3, it will tell us that the previous hash, the hash of block number 2, should be 6BQ1. It will say, there's something wrong here. Somebody tried to change information. So once somebody tried to change information, we will reject this transaction. Now, the ledger is maintained by a network of nodes, with each node having a copy of the entire ledger. So for example, if I have 50,000 nodes in the network, all of these 50,000 nodes will have access to this ledger. They will all have a copy of this ledger. Transactions are verified and added to the blockchain through a process called mining. We will elaborate it later, which involves solving complex mathematical problems to create a new block. Now, once a block is added to the chain, it cannot be altered or deleted. This is because each block contains a unique code that we call a hash, as we explained earlier, which is based on the contents of the block and the hash of the previous block. So if anyone, as we said, tries to change the transaction or a block, the hash would no longer match and would be rejected by the network. So in summary, blockchain is a decentralized, distributed, and immutable ledger that relies on a network of nodes to maintain and verify transactions. It uses cryptographic algorithms and consensus mechanism in order to ensure the transactions are secure and cannot be altered. We have another use case for blockchain that is called smart contracts. We will talk about it later in this session. Do you have any more questions about the things that we have been discussing about right until now?